Welcome to Web Handling. My name is Dave Roysam. I am super excited to continue our Material Matters mini-series with a discussion of hygrothermal expansion. What is that, you say? It is the changes in dimension caused by changes in temperature or humidity. Who cares, you say? Lots of people should. Let me explain why you should too in the next few slides. Expansion is a fact of physics, and that has many effects. Machines that are a meter or more wide may need special designs and special assembly methods for rollers and other cross-machine components. Webs that are a meter or more wide may be at risk of wrinkling due to increases in temperature or humidity. Product and process designs may require us to consider or reconsider the temperatures and, in some cases, moistures seen by your product during its entire life cycle of manufacturing, converting, storage, transportation, and end use by your customer. So, what is hygrothermal expansion? It is simply the change of length, width, or thickness of a web due to changes in moisture or temperature. It is simple because the equation to calculate it is a simple one-liner that you may have seen in high school physics. For example, the change in width is the original width times alpha delta T, where alpha is the coefficient of thermal expansion and delta T is the change in temperature. An analogous equation shows that the change of width for materials such as paper that have an affinity for water. The differences between moisture and temperature effects are mostly trivial. It is now the coefficient of hygroscopic expansion and the change in moisture. That is why we use the word hygrothermal behavior to capture both sets of behaviors, because they are almost identical in everything from expansion to Fick's law diffusion. Most of the time you can merely Google expansion rates for common materials and you may find what you need. If your web is uncommon and not listed somewhere, you can measure expansion rates with one of several different test methods given in our must-have 750-page Web Handling Handbook. From the length of this list, you can rightly conclude that many people consider expansion to be important. So, let us start way back at the design stage for your machine. The builder should have calculated the expansion of rollers and other cross-machine beams. Given here is an example of a roller in a medium-width machine that will expand about 5 times the thickness of a human hair due just to variations in room temperature. Oven temperatures are 10 times that. So, who cares about 5 or even 50 hairs thicknesses? Well, the bearings do. You can send bearings into overload and catastrophic failure within minutes, especially if the framework is stiff, as it should be. So the designer may need to accommodate thermal expansion by choosing a fixed-free or a free-free bearing design. Furthermore, the mechanic must assemble them towards the cool end of their travel. While this is beyond the scope of this introductory clip, you can find all the details of design and assembly in the roller chapter of the must-have 750-page Web Handling Handbook. Perhaps even more trouble than destroying a few bearings is to destroy your web or your wound roll due to what is called constrained expansion wrinkling. While we can free a bearing to accommodate expansion, webs that are a meter or more wide simply usually cannot move their edges outward, even though intuition might tell you that should be easy. Instead of moving edges out to accommodate width increases caused by increases in moisture or temperature, the web moves out of plane into wrinkle troughs. Thus, instead of moving the edges out due to increases in moisture or temperature, the outer layer of the wound roll moves into bumps that are called moisture welts when on paper rolls and tin cans elsewhere. We see this web misbehavior on a truly staggering variety of processes, such as air-float ovens, IR or UV dryers, steam foils, as well as water-based coating or water-based printing of paper. We see this wound roll misbehavior on a wide variety of products, including paper stored in an unconditioned warehouse or during transoceanic shipping of paper, or film in a vacuum metallizer. So, how much expansion can you get away with? Surprisingly, the answer is similar across a wide variety of webs and wide variety of processes. In round numbers, at 1 part in 1,000 expansion, you have few problems. However, at 1 part in 100 expansion, you have few products that are commercially viable. I include some sample examples here. Of course, everyone wants to be the exception to the rule. I ran into one exception just 2 weeks ago, though they struggled for nearly 1 year to get the coder to play nice with the web, and had to go through a dozen paper grades to find one where the expansion was slowed by a special treatment called sizing. So being an exception can be exceptionally costly and exceptionally time-consuming. So rather than just wing it, I would suggest that product process designers literally go to school. I go into great detail about this type of wrinkling in Module 9 of my award-winning and trademarked Web201 class that has been taken by 5,000 students just like you. Alternatively, there is a similar discussion in 2 chapters of the must-have 750-page Web Handling Handbook. From the must-have Web Handling Handbook, we have a table of the thermal expansion rates for common web materials, mostly films. Also, a quick Google search will give you expansion rates for metals, though I should have added aluminum here because many idler rollers are made of aluminum. It is slightly more than steel. Roughly, most metals expand 10 microinches per inch per degree F, or in metric, 20 microstrain per degree C. Somewhat harder to find, unless you have the must-have 750-page Web Handling Handbook, are hygroscopic equilibrium moisture contents and their corresponding expansion rates. Note that paper is quite lively. Also note, as you would expect from anisotropic materials, paper's expansion in the CD is 3 times what it is in the MD. It is also slightly grade dependent. In round numbers, web width will change a little less than 1% for a 10% change in moisture. This is not at all small, as anyone who is involved in specifying dimensional tolerances of paper or fiber cores will tell you. We cover fiber cores in great detail, including hygroscopic effects on core length and loose cores in the advanced winding section of my Web 101 class, so there's no need to do that here. Just because environmental temperature changes does not mean the web's temperature will change immediately. Just because environmental humidity changes does not mean the web's moisture content will change immediately. These and other physical processes take time. The details are covered in great detail in my Moisture Effects on Webs and Rolls article in the Tappy Journal, as well as in my Web 101 class. I will write and render and post on these details on this all web handling channel of YouTube this summer, so please subscribe so you don't miss a thing. We have outlined many hygrothermal concerns here, yet there are many more not even outlined here, such as thermal profiling of nipped rollers and environmental web curl, to name just two. There are 3 places where you will learn more about hygrothermal expansion and its application. The first is the long-awaited, must-have 750-page Web Handling Handbook, written by myself, Tim Walker, and Dilwyn Jones. Second is the curl calculator that is a free and easy internet app by Avid Apps. Here you can calculate the stability of your product during converting, transport, storage, and end use due to changes in temperature and moisture. Last but not least is my award-winning and trademarked Web 101 class that has been taken by about 5,000 students just like you. Here you will learn how to use material properties and testing to size and maintain and operate and troubleshoot web machinery. Thank you so very much for joining me in this Material Matters series. Stay tuned for the next clip where we discuss Poisson's ratio, what it is, how you test for it, and why it is super important for some webs. If you have a topic you would like to hear about, let me know in the comment section below. If you found anything interesting or useful here, please like and share and subscribe. Also, please consider supporting the work of this channel using the Patreon link below. See you next time.